So today's video is going to be about the urinary system. We're going to be looking specifically at the kidneys and how they produce urine, how they filter the blood, and then how that urine later is expelled from the body. So let's start with the basic functions of our urinary system. So our first function here is just going to be that it excretes liquid waste. Liquid waste is called urine. Our second function is that it helps us retain water and salt. By helping us retain both water and salt, that's how it's going to help maintain our water levels within the blood. It also helps maintain homeostasis, and it does that in a variety of ways, not just with maintaining water levels or salt levels. It also helps maintain blood pH and a few other things that we will look at more specifically as we move through. Okay, so let's zoom in a little bit on the kidney in particular. So as we can see over here on the side, this is obviously a kidney. Okay, we're going to look at kidney anatomy a little bit later, but the kidney is going to be our main, our only organ that's going to actually form urine. Okay, so focusing here on the kidney specifically. So one of the things that the kidney is able to do is it is able to control the volume of water that is in the body. By controlling the volume of water in the body, that also lets the kidney help control blood levels, so blood volume and blood levels, as well as blood pressure. If you remember from our heart unit, when we talked about blood pressure, right, one of the things that can impact blood pressure is the amount of blood volume. Blood volume becomes too high, then blood pressure will go up, blood volume becomes too low, and blood pressure will go down. So by the kidney controlling the volume of water in the body, that's essentially controlling the volume of blood as well as the blood pressure in the body. We said earlier, a minute ago, that the kidney was also able to help control blood pH. Remember, pH levels are acid-base levels. So just a quick reminder there. So remember those acid-base levels, 7 is neutral. When we get further lower, but further away from 7, so closer to 2, 1, 0, we get more acidic. As we get higher, closer to 14, we get more basic. Again, we'll talk a little bit more later of specifics on this, maintaining hydrogen ion concentrations. For now, let's just realize that it can help us regulate our blood pH or our acid base levels within our body. The kidneys will also help regulate what's called blood osmolality. Osmolality is essentially the saltiness that is of the fluid. And so what the kidney will help do is it will help regulate the number of dissolved molecules per unit of volume of fluid. So for instance, salt ions, potassium ions, right? It's controlling the concentration of these various ions. Again, common ones being sodium, chloride, potassium, magnesium, as well as calcium. But maintaining the different concentrations of these ions will impact that blood osmolality, or what we call the saltiness of the blood, of the volume of the fluid. Kidney will also make some hormones for us, including erythropoietin. Erythropoietin helps make more red blood cells, as well as renin, which is going to impact blood pressure. If you remember, we talked about this one before. Right now, we don't need the details of what these two do, just giving examples of hormones that the kidneys can make. The kidneys will also convert vitamin D into its active form. So we're not converting vitamin D into something different completely. We're just taking the inactive vitamin D and converting it into its active form. So it's a pretty long list of things that the kidneys can do. It's definitely longer than just make urine. So make sure that you get this list down, right? That we're controlling the volume of water in the body, regulating blood pH, regulating blood osmolality, making hormones, and converting vitamin D into its active form. Let's look a little bit closer at the kidney anatomy and where the kidney is. So the kidneys are what are considered retroperitoneal. Retro means back or behind. So these are behind the peritoneum. If you remember, the peritoneum is that serous membrane that covers the organs within the abdomen. So maybe just a reminder there. So that peritoneum is surrounding our intestines. It's surrounding our stomach. That peritoneum, the kidneys are not located within that. They are behind that, embedded on either side of the lumbar spine. So they are way back there. So we're looking at this picture over here on the side. We can see the kidneys right here. Okay, we've got a right kidney, we've got a left kidney. The liver is pushing that right kidney down. That's why it's down a little bit lower, because the liver is over there. So in front of this, we would have stomach in front of this. We'd have all the intestines in front of this. Okay, so the kidneys are way in the back. If you watch boxing or MMA, right, when they're going for that kind of low back right near the bottom of the rib cage area, they're going for kidney shots there. So they're embedded in that back wall and that muscle on the back wall there. They are usually cushioned by fat because they're not fully surrounded by the ribs, as you can see in the image here. They aren't completely surrounded by the ribs, so they don't get full, coverage and bony protection. About half of them are covered by the ribs. So there's some fat there to help protect them and surround them. And then on top of the kidneys there, you'll see those yellow adrenal glands. Okay, and those are sitting right on top of each kidney. And those adrenal glands will produce epinephrine and norepinephrine, which is very important in our sympathetic nervous system responses. So zooming in even closer onto the kidney itself, the kidney is divided mostly into these two parts. We have the renal cortex, which is right here. The renal cortex is this outer layer here. So in this image here, it's this kind of lighter pink area. And then you have the renal medulla. And the renal medulla is this almost striped looking area, this darker red looking area. That's the renal medulla. And the renal medulla is divided into renal pyramids. So we can see down here. Okay, so each one of these kind of upside down looking triangles is considered a renal pyramid. This whole section is renal medulla within these individual renal pyramids within that medulla area. Those renal pyramids are separated by renal columns. Okay, so this is the area going down in between the renal pyramids. And then at the tip of each renal pyramid, you'll see a papilla. So that's this area right here. It's the point, essentially, of the pyramid. That's where things are going to start to kind of drain down into the renal pelvis from there. The renal pelvis is this central area right here. And that renal pelvis is what's going to drain into the ureter. So the urine will come through that renal pelvis and then down into the ureter here. And that ureter is then going to connect that ureter is then what connects the kidney down to the bladder. We'll talk more about that at the very end. But for now, in our kidney discussion here, this renal pelvis here is essentially where the urine collects and then drains down into the ureter. So let's talk a little bit about our nephron. The nephron is our basic functional unit of the kidneys. If you remember from the bone discussion, the osteon was that functional working unit of the bone. The nephron is the same for the kidney. Each kidney contains millions of nephrons. This is where the urine's actually being made. The filtering process is happening here, the reabsorption, the secretion, that's all happening here in this nephron. The nephron consists of two parts. It has a renal corpuscle. You can see it in the picture here, and we're going to talk about each part individually in a minute. So there's a renal corpuscle, followed by a renal tubule, which is this big whole part right here. Okay, so that's the two parts of the nephron. And like I said, we're going to talk about each one individually right now. Okay, so focusing first on the renal corpuscle. The renal corpuscle is made up of the glomerular capsule and the glomerulus itself. The glomerulus is a capillary knot. Remember, capillaries are very small blood vessels. So as I'm looking at this image over here, this is my glomerulus here, and I'm following this capillary knot here, this blood vessel knot. That's the glomerulus. And then you can see it's surrounded by the glomerular capsule. The glomerular capsule is also called Bowman's capsule. Those two things are the same thing. So I have the outer capsule surrounding this knot or hunk of capillaries. You'll notice those capillaries are all covered with what are called podocytes. Podocytes are those purple-looking kind of sea anemone looking things on the capillaries here. Those podocytes, podo means foot. Those are foot cells. Foot cells being in that they're able to wrap around the capillaries like this with those extensions. So those podocytes wrap around the glomerulus capillaries. So they wrap around these little blood vessels. And then the blood plasma is the fluid that's in the blood. So the blood plasma can then leak out of the capillaries through these filtration slits. So like, for instance, where you can see the glomerular capillary right here, that is also the site of a filtration slit there. So the blood plasma can leak through that filtration slit, and it will actually end up in the glomerular capsule. So it'll end up in this space here so that it can then flow down the proximal tubule. So this will be kind of the beginning first part of urine formation, is getting some of the fluid out of the bloodstream so that we can check it and filter it and monitor it and see what's going on with it. So the vocabulary in this unit is pretty unique. So you're going to want to make sure that you're practicing with it a lot and you're practicing, saying and using these words so that you can remember them. So the renal tubule is the second part of the nephron. Remember, this is all part of the nephron. The nephron consists of the renal corpuscle and the renal tubule. The renal tubule is going to be divided into three parts. The first part is going to be the proximal convoluted tubule. You see your spelling for that is right here. So this is the first part. So the filtrate, that beginning urine formation, has come out of the capsule. You can see right here. It's come out of the capsule and into this convoluted tubule, which is what it looks like, right? Like a big giant mess of a tubule. So the fluid that was entered the glomerular capsule that went from the capillaries through those filtration slits in the podocytes goes into the primary convoluted tubule and will enter the nephron loop. So the nephron loop is the second part. The nephron loop is also sometimes called the loop of Henle. The nephron loop has both ascending and descending portions. So that is, the loop is this right here, just a straight up and down. So it has ascending and descending parts. The nephron loop is located sometimes in the cortex, sometimes in the medulla. Longer ones will go down into the medulla. Shorter ones will stay up in the cortex. And then the, big typo. And then the third portion is the distal convoluted tubule, which is part 3. You can see right here. So again, it's convoluted, big giant mess, right? Messy and crazy, all different directions, not in a nice straight line. So the distal convoluted tubule is going to pass the fluid onto the collecting duct. The collecting ducts will drain. So you can see your distal convoluted tubule coming here into the collecting ducts. Those collecting ducts eventually end up in the renal pelvis. And if you remember from before, the renal pelvis was that area of the kidney that would drain down into the ureters. So again, the proximal convoluted tubule and the distal convoluted tubule, those are both located in the cortex. And then the nephron loop, or the loop of Henle, is sometimes in the cortex, sometimes longer down into the medulla. Regardless of the part, all three parts are surrounded by capillaries. As you can see, there's a lot of capillaries happening here as the fluid is moving back and forth between the blood and the kidneys. So all three parts are going to be surrounded by capillaries, and there'll be different roles in each part, whether the fluid is leaving or entering the capillaries. So let's take a look a little bit here at what blood flow looks like as we kind of summarize what's happening here in the kidney as the blood is moving in and out of the kidney. So the blood is going to enter the kidney through those renal arteries. Renal is kidney. So anytime you see renal, you need to be thinking kidney. So blood is going to enter through those renal arteries. It's then going to go into an afferent arteriole. Afferent arterioles are going to be the capillaries that are entering the glomerulus. So that's going to be, those afferent arterioles are what are going to be bringing blood into that glomerulus area, which will, that blood that's going to then leak out into the capsule. So you can see those here headed in. From there, the blood will go into the glomerular capillaries. And that's where, again, we'll see some of the plasma will enter that, that capsule. So some of the plasma will enter the glomerular capsule through those glomerular capillaries. So that blood fluid will be able to get fluid. Okay. From there, things will move through. The blood itself will then exit the glomerulus. You've got the filtrate that was from the plasma that entered the capsule. That's doing its different thing, going into the going further into the nephron. So the blood will then exit the efferent arteriole. The efferent arteriole will then lead to capillaries. These capillaries are going to be the ones that we talked about that are surrounding the proximal convoluted tubule, the distal convoluted tubule, the nephron loop. These are the particular capillaries that are there, which makes sense, right? The blood has come into this glomerulus here. We pulled some filtrate out of it. We worked that through all these tubes. That original blood is now what's surrounding those tubes, so that original blood can pick back up essentially the cleaned up fluid that the kidneys are helping make. So it will, those capillaries, they're going to be able to reabsorb fluid, not waste, right? They're going to be avoiding any waste products here that entered that capillary, that capsule space. And then from there, the blood will flow out through the veins, and it will eventually exit the kidney through those renal veins, is how it's going to eventually completely leave the kidney.